In this lesson, we will look at some applications of sequences and series. So you may or hopefully remember that in previous lessons we've seen formulas for arithmetic and geometric sequences and series. So just recall that a sequence is a list of numbers. Basically, just that's it. It's a list of numbers. To be an arithmetic sequence, there's a common difference. So from one term to the next, it's going to be going up or down by the same amount each time. So if I'm adding a number or subtracting a number from one term to get the next term and it's following that pattern, that's an arithmetic sequence. An arithmetic series is just the sum of an arithmetic sequence. So if instead of making it a list, I add them together, then it becomes a series. A geometric sequence is a specific type of sequence. In this case, the terms are related to each other by multiplication. So if I have to multiply one term by a certain ratio, a certain multiplier, then I've got myself a geometric series. Sequence. And to be a series, that's when we add them together. All right, so I'm going to look at just a couple examples here. And the trick for doing these is to ask yourself those questions that were just implied in my recap there. Are we dealing with a sequence or a series? In other words, do I care about particular terms, or do I care about the sum of adding them all up? That would help me decide between sequence and series. And the other decision is it arithmetic or is it geometric? Are the terms going up by a regular addition or subtraction, or are they going up by multiplication and division? So, example 1, a new computer software company earns a profit of $125,000 in its first year. The company expects the profit to increase by 25% each year for a subsequent year. All right, so right away, I can, before I even get to what the questions are, I can decide, I know what's going on as far as whether it's arithmetic or geometric. If it's increasing by 25% each year, that's a proportion. It's a proportional relationship, which means it's involving multiplication. This is going to be a geometric sequence or series. It's not adding. If it said something like they're going to add $25,000 every year, then it'd be arithmetic. But each year is going to add a certain amount more. So if I take 25% of 125 to add it for the second year, then obviously I'll have a bigger amount, and it's going to go up by more the next year, the third year, and then more again by the fourth year. Again, it's a regular multiple, that 25% increase, making it geometric. Determine the formula to calculate the company's profit each year and use it to determine the company's profit for the seventh year. So for the profit each year is going to form a sequence. So it's $125,000 for the first year, and then it's 25% more for the next year, and 25% more again for the next year. And again, geometric. So if you remember, the formula for a geometric sequence was given as T sub n, so term number n, is A times R to the n minus 1, where A is the initial amount, that's $125,000. Let's just write them out here. So that's the $125,000. R is the ratio. So remember, when we're dealing with powers and we're increasing by a percent, we have to start with that 100%, and then we either add or subtract. We add a percent to that 100% if we're going up, and we subtract from 100% if we're going down. So it's increasing by 25% each year. So each year, the profit is going to be 125% of what it was the previous year. But when we're working with things, when we're working with these formulas, we want to change percents to decimals. So 125% as a decimal is 1.25. And then n is just the number of years that have gone by. So in this case, the seventh year, n equals 7. So it's just a matter of plugging these numbers into their various places and then putting them in the calculator. So 7 minus 1 is obviously 6, but I just want to write it down so that we can have it to see, at least for starters. 125,000 times 1.25, and I will just do exponent 6. I'll simplify that. So in the 7th year, the profit is 476,837. Just double check I wrote that down right. Yes, I won't worry about the cents. I'll round it to the nearest dollar. So at 25% increase each year, again, it's forming an exponential function, really. So geometric sequences and series are very closely related to exponential functions. So if the profit was 125,000 the first year, then year by year, I guess that would be year 0. It's the way I've written it there. Let me just put that over here. I don't want to put it on the y-axis. So I'll put it over here, 125,000 at year 1. But then at year 2, it's going to go up. And then year 2, it's going to go up a bit more, and then a bit more. And so it forms this exponential shape that we've come to recognize, that curving upward shape. The 7th year would be, 2, 4, I haven't quite got it on here, but it'd be something up here. So it's growing, and this is not to scale at all, but it's growing more than it would have if it was arithmetic, where we were just adding the same amount each time. If I want to find the sum total profit the company will earn in its first 10 years, well, I can predict that's going to be pretty good at adding those 10 years together, especially when we consider the 8th, 9th, and 10th year are going to be even better than the 7th, but we got a formula for that too, right? We're still dealing with a geometric series in this case. So for geometric series, I'd probably want to use the formula S sub n equals A, because I know the initial amount, times R to the exponent n minus 1 inside brackets over R minus 1. So that's going to be the $125,000 I started with times the 1.25 to the exponent 10, but I'm going to subtract 1 from that. And then I'm going to put that over 1.25 minus 1. So that's just going to, the denominator is just going to simplify down to 0.25. So again, let's just type that all in at once. So $125,000 times, I'm going to use brackets, 1.25 to the exponent 6, then minus 1 here, and then divided by 0.25. I'll simplify that. 1,407,348. That sounds reasonable based on the fact that, again, the 7th year they made over $400,000 profit. I can expect more in the 8th year and the 9th year and the 10th year. The majority of the profit comes from the last years of the sequence. 1,407,348. So that would be the sum for the first 10 years. So again, the decisions I made, the formulas I used, were based on 2 decisions: sequence or series, arithmetic or geometric. So with one more example, and we have to make those decisions again. Let's read through the question first. A new theater in Uxbridge has been proposed to have a total seating of 4,000. The first row has 105 seats. Okay, that would be term 1. And the number of seats in each subsequent row increases by 10. So we have 10 more seats per each row. So then it'd be 115, 125, and so on. How many rows are there? So the question is asking us how many rows are in the theater. So we can probably guess that that's, or maybe we can't, but what it's going to be is we're trying to find out what n is. So again, we have to ask ourselves, is this arithmetic or geometric? Is it sequence or series? Well, we're going up by the same amount each time. 10 seats each time. It's not a multiple, it's an addition. Addition and subtraction means that we've got something arithmetic. Whoops. And if we want to know, well, we're not trying to find the sum or the specific term. We're trying to find one particular, we're trying to find n, the number that would, of rows that we would have if we had a sum of 4,000. So definitely, I guess what I'm trying to say is this is related to a sum, right? The 4,000 is a sum. And when it's a sum, that makes it a series. So we're dealing with an arithmetic series, is what it boils down to. I want to find n, so I want to use the version that says S sub n equals n over 2 times 2a plus n minus 1 times d. So I've got to find out what n is in this formula, but I know everything else. I know that the sum for however many rows it is 4,000. I know that the initial amount, A, is 105 seats in that first row. I know the common difference is 10 because it goes up each time. So now all I have to do is plug these in and solve the equation for n. So let's do that. All right, so we can simplify a little bit. 4,000 equals n over 2 times 205. And then I can, 210, my mistake, 210. And then I can do distributive law here. I can multiply both of these by 10. So plus 10n minus 10. And I can simplify more, but I'm going to have to start isolating n. So maybe at this stage, one thing I could do is I could multiply both sides by 2. That'll get rid of the 2 on the bottom of this fraction. And if I multiply the left side by 2, I'm just going to end up with 8,000. So multiplying both sides by 2, I get 8,000 on the left side. Now I've just got n without it being over 2 here. I can simplify a bit more. I've got 10n. And then if I combine the 210 and the minus 10 together, it's 10n plus 200, right? So a bit of simplification. I can expand this out, and I can bring the 8,000 over to the other side. Let me explain why after I do it. Well, actually, let's do it together now. N times 10n gives me 10n squared. N times 200 gives me 200n. I've got a quadratic going on here, right? So the fact that I recognize this as a quadratic that I'm going to want to solve means that I should put it in standard form because that's how we solve quadratics. So that's why I will also bring the 8,000 over to the right side at this time because now it's a quadratic that's in standard form and I can solve it. And now I'm going to solve it by factoring it. So first of all, I'm going to look for a common factor, as always, when I'm trying to solve a quadratic, and it's pretty obvious that I can take 10 out as a common factor. So I'll start with that. Then I'll try to factor what's inside the brackets. If I can, then great. That'll save me time. If not, I can use quadratic formula. But that one, I think, is factorable. Two things that are going to multiply to give negative 800 and add to give positive 20. Well, I could even just think what's going to multiply to give negative 8 and add to give positive 2, and then just add zeros on both of them. However you want to think about the factors, I think that positive 40 and negative 20 will work, right? 40 times 20 is 800. One's negative, so it's a negative 800. 40 minus 20 is 20. So from this, I can say that n equals negative 40 or n equals positive 20. Again, this is one of those cases where it's a word problem, so certain things won't make sense. Remember what n is. It's the number of rows in a theater. I can definitely have 20 rows in a theater. I can't have negative 40 rows in a theater. That just doesn't make sense. That's one of those extraneous roots that we're not going to worry about. So the number of rows under these conditions that will give me a total seating capacity of 4,000 is going to turn out to be 4,000. Sorry, 20.